Now, I have been thinking about this for a long, long time. I have been thinking whether perhaps this could not be shown in a more dramatic way, perhaps even a more convincing way. And so I thought of the idea of putting a bathroom scale under my feet, tying it very loosely so that it wouldn't fall off when I jump. And then show you that while I'm half a second in free fall, that the bathroom scale indeed indicates 0. And don't think that I haven't tried it. I have tried it many times with many bathroom scales. I made many jumps. There's a problem. And the problem is the bathroom scales that you buy, that you normally get commercially, they indeed want to go to 0. It takes them a long time. They have a lot of inertia. Their response time is slow. But even if they make it to 0 by the time you hit the floor, then immediately the weight increases because you hit the floor and your weight comes up by 3.5 times. So it begins to swing back and forth and it becomes completely chaotic and you can no longer see what's happening. And it just so happened that about 6 months ago, Dave, I had dinner with Professor Dave Trumper. And I explained it to him, that it is just unfortunate that you can never really show it, that you jump off the table, have a bathroom scale under you, and see that weight go down to 0 when you're in free fall. And he said, duck soup, I can do that. He says, I can make you a scale which has a response time of maybe 10 milliseconds. So when you jump off the table, in 10 milliseconds, you will see that thing go down to 0. And he delivered. He came through. He built this wonderful device, which he and I are going to demonstrate to you. Let me first give you some reasonable light for this. And I would like to show you on the scale there what this scale that he built is indicating. Here is the scale. I have it in my hands. And on top of this scale is a little platform, just like on your scale. This platform weighs 4.5 pounds. And you can see that. It says about 4.5. Now you will say, I wouldn't want that kind of a bathroom scale. I mean, if I want to see my bathroom scale, I want to see a 0 before I want to go up. I'm heavy enough all by myself. I don't want to get another 4.5 pounds. The manufacturer has simply zeroed that scale for you. But obviously also your bathroom scale has a cover on it. Once you have seen these demonstrations, you will be able to answer for yourself why we don't zero this, why we really leave this to be 4.5. That's the actual mass which is on top of the spring. Well, it's not really a spring, it is a pressure gauge, but think of it as a spring. 4.5 pounds. Here we have a weight which is a barbell weight, which is 10 pounds. Is this from one of your children, Dave? Or you're doing it yourself? 10 pounds. We put it on top here. What do you see? Roughly 14.5 pounds. All right, we're going to tape it down. There we go. And we're going to drop it from about 1.5, 2 meters. And we drop it in here. It's well cushioned, because we don't want to break this beautiful device. When we drop it, the response is so fast that you will see indeed that pointer go to 0. Now keep in mind, when it hits the cushion, that the weight will go up. For now, I want you to concentrate only on the thing going to 0 and not what comes later. We will deal with that within a minute. Okay. 14.5 pounds. You know why the thing is actually jiggling back and forth? I can't hold it exactly still. And so I slightly accelerate it upwards and downwards. And when I accelerate it slightly upwards, it weighs a little more. And when I accelerate it downwards, it weighs less. It's interesting. You can see I'm nervous. Here, that's my nervous tension meter there. Okay, we ready? Don't look at me now. Look at that pointer. 3, 2, 1, 0. Did you see it go to 0? All the way to 0. Now comes something even more remarkable. He said to me, I can also make the students see the response on a time scale of about a fraction of a second. By the way, this is the hero who made all this stuff. He's fantastic. He can show you the weight on an electronic scale, and this weight you will see as a function of time. I'll put the 10 pounds back on again. Tape it a little tighter. And so the level that you see now is 14.5 pounds. This is 14.5 pounds, and this is 0. This mark is 0. I'm going to hold it in my hand. And notice, if I can hold it still, you're back to your 14.5 pounds. Now I'm going to drop it. You will see it go down to 0. It will hit the floor, the cushion. It will get an acceleration upwards. It will become way heavier than it was before. And then it will even be bounced back up in the air. It goes again into free fall. We will freeze that for you, and we will be able to analyze it then after it all happens. So, 14.5 pounds, 3, 2, 1, 0. And now Professor Trumper is freezing it for you. Now look at this. Look at this incredible picture. This is truly an eye-opener for me when I saw it. The physics in here is unbelievable. Here is your 14.5 pounds. Tick marks from here to here are half a second. It was half a second in free fall. And it goes to 0. That's no weight. Now it hits the floor, the cushion. And its weight goes up in something like a tenth of a second. Look, this is about 1, 2, 3. It's about 3.5 times its weight now. So the 14.5 has to be multiplied by 3.5 or 4, which is exactly what we predicted, that it would be much higher. But now it bounces off because it's a very nice cushion. It throws it back up. So it goes back into the air, so it goes immediately to weightlessness again. And then it oscillates back and forth. And then here, you would expect that this level 14.5 pounds would be the same as this. And the only reason why that's not the case, there is a little cable that fell with it, which is pushing a little bit up on the upper disk that is there. So it's making it a little lighter. Isn't it incredible? You see here in front of you the weightlessness, and you see the extra weight when it hits, and again followed by weightlessness. Dave, A+, you passed the course.